Hey everybody, this is Dan. I am giving you an update video for section 8.5. This is in the part of the course where we're studying deviations. And I just wanted to clarify a few things and talk about the chi-square distribution a little. On this one, we're looking at, I just did a few problems here, and this is in the homework that's written, or I'm sorry, the notes that are written up online. One thing I want you to add is I failed to add this chi-squared calculation. How do you calculate the chi-squared statistic? With these problems, what we're trying to do is hypothesis testing about the deviation, of standard deviation. So, for instance, this is a soda drink factory, and they're filling up their cans, and they've measured they took 21 cans, measured the average and standard deviation, and they're testing a claim that's they typically think it's 0.14 ounces is the standard deviation. The question is this sample significantly less than that? Have they lowered the standard deviation? So here's what you need to add. The chi-squared statistic is the stat we use to measure variation. So you just take the sample size minus 1, so in this case it's 21 minus 1. They give us the sample standard deviation, which is 0.12, and here's the population standard deviation, what we think it is 0.14. So that's the only thing you really need to add. There will not be a question on your test or final over this type of problem, but I want to at least help you get through these section 8.5 homework. It is important, but I'm not going to put one of these on your test. I'll probably just put one for confidence intervals for the variance or standard deviation, and then maybe one on the F test, which is the end of this week. So anyway, so if we calculate this chi-squared, we put 21 minus 1, 0.12 squared, 0.14 squared. So we get a chi-squared statistic of 14.69. You're like, okay, is that good or bad? Well, we could pull up the table and kind of look at it and say, what's the probability of getting this? So like if this is the chi-squared, it's like skewed to the right. 0 is on the left side. This point right here would be like 14.69. So the question is, what's the probability of getting this much variation or less? And if we use the chi-squared calculator on StatCrunch, we're going to get 0.2064. So I'm going to show you how to do that. So I'm going to go to StatCrunch here. And if I go to Stat Calculators, chi-squared, so Stat Calculators chi-squared, and you just put in the degrees of freedom, and that was 20 degrees of freedom. Our chi-squared statistic was 14 point, oh, what was it again? 14.69, and we hit compute, and there it is. So that gives us the area below that. Now, if the alternative hypothesis is greater than, it would be the area to the right, which would just be that way. And some of the questions are actually two-tailed. So if I want to make this two-tailed, if this is a two-tailed test, like not equal to 0.14, then I would just double this. Some people are asking, well, how do I know if it's left or right when I double? It'll be based on your alternative hypothesis. And obviously, if it's two-tailed and you had this, you can't have a probability over 100%. So that's a good hint that you should probably use the lesser and then double it if it's two-tailed. So there's the chi-squared calculator. If we're going to use our chi-squared table, I'll go ahead and pull that up. So I'll go to course content here, chapters 7 through 9, textbook and review materials, and here's the formula sheets. And let's go ahead and pull up this chi-squared table. So if I look at this one, if I look for row 20, that's what we should be, and we're looking for like 14 point something. As you look right here, you can tell it's to the right of this one and to the left of this one. There's a huge gap here. Well, the reason is we're only looking at the tails. If we find chi-squared statistics that are kind of in the middle here, it doesn't really make that much difference to us. We really only care if we find extremes, like extreme low or extreme high deviations. So this is what this means. So this is like 0.995 is to the right, which means there's only 0.005 to the left. And this one is 0.99 to the right. This always gives us to the right. And then these are the right tails. So this would be like, 0.025, means only 2.5% to the right. So these would be the chi-squared. So if we wanted a significantly low, let's say less than 5%, one-tailed, that would be right here. we would need a chi-squared under, for row 20, under 10.851 to reject the null. Or if it was a 10%, if alpha was 0.1, we'd need to be under 12.443. So this is the table you'll have for the test. This will be just fine because it'll tell us kind of which range of probabilities it is. And then for the ones on your homework, you'll need to use the chi-squared calculator. So I hope that helps you with section 8.5, and shoot me any questions. We had some good posts in the FAQ discussion board as well about this. All right, talk to you later.